Okay, by this point, you should have completed the moose game analysis, and now we are going to talk about kind of our notes, what we learned, why we did this, and apply our knowledge to the greater population. So not just the moose and the wolves on Isle Royale eventually. Right now, we're still on the island. So what might we also want to know about the moose? So this is why we played the game. We wanted to look at the moose population to see if it could shed more light to connect with what the wolves are doing. And here is our graph. I want you to take a moment and think about, is this what you would have expected to see with the wolves on the island, or sorry, the moose on this island? Maybe why or why not? Just think to yourself for a second while I get our notes up. Take a look at the graph, look at the trends, look at what's going on, maybe look at the end, look at where this middle section, what's happening there, and try and like describe it in a few words. And given what we know about the moose from our readings and the game, we're going to try to figure out what factors we think might be affecting the size of the moose population. The moose, not the wolves, moose, on Isle Royale. So we are going to get into box E on our notes. So I just have on block 1B up just because that was the first one I had. Go to your classwork. And remember, scroll down. It is our population dynamic notes number 4. You want the one with the pencil because that is your notes that you have been writing on. If you've already been writing on these and you have them, it's going to be in your drive again. So just go into the search bar here, type in Google Drive, and find your document that you've been typing on. I've been keeping mine shared with everyone, so I do not have any of the notes from previous times. They're all on the videos that I've been sharing with you. Okay, so what is going on with the moose population? Right now, we're going to think about factors that might contribute to these ups and downs. And remember, we use that word fluctuation. So those fluctuations we see in the moose graph. So some things that have already come up in a few classes that we talked about, or things that you learned from the actual game, was maybe the predators that they have. And remember, those predators specifically on the island are the wolves. Why didn't capitalize? There we go. You guys talked about weather or climate could have a factor. Some classes told me about resources. You guys talked about like food, water, habitat, shelter, things like that. Some people that weren't thinking about the island specifically talked about hunting. I'm going to put in parentheses, not on Isle Royale, because remember, the island is a national park and it is protected by the United States as a protected land where humans cannot cannot destroy or take away from the island. So the island is protected and there's no hunting on the island. Okay, and if you had any other ideas from the class that I did not mention here or that we talked about in our classroom, if you're with me today, then you can add those other ideas. But otherwise, I think we got them all. All right, so overall, what we saw in the game, the moose game, that I know you guys all love so much, do our game results help us to understand what is happening with the moose population? So let's just think about this. Did our moose population always survive crazy times? Or did sometimes were they sharing in the chat or sharing with you that all their moose died? Like, just think about, does what we saw as a class or a cohort, maybe not specifically you as an example, but as a class or a cohort, did it follow kind of these trends or patterns? I want you to just think about that, hypothesize on that idea for a moment. So we're going to try and make sense of this. If you were in class for this discussion, you'll already have known this part, so you can skip ahead a little bit. But if you were absent or you missed it or whatever, I'm going to go through some of these sections. So we're going to take a look at 3 different parts of this graph and see if it is increasing or decreasing the population. And then we're going to talk about how we knew this. So I'm going to pick the purple section first, which is 1966 to 1973. If you look, the population went from about, I don't know, we'll say 550 moose, all the way up to here, I would say 1250 moose. So it went from like 550 to 1250. That's an increase. So that means more wolves are, or sorry, wolves, more moose are alive. That means more babies are being born. That means more survival for the mom. That means that they're not dying or getting eaten. So in this purple section, this increase in our graph is an increase in moose. More are living. And then we'll take this next section, the yellow section, where it kind of goes on a downward slant or kind of a downward slope, where it's from 1974 to 1980. We can see the most were, again, probably at 1250, and it shot all the way down to like 700. So this would be a time where you need to think about what was killing your moose in the moose game. Because obviously the moose abundance was going down. Therefore, there was less moose to survive in that time. I do want to take a look at kind of like a specific section. It is not like explicitly stated, but it is something we need to talk about. So I'm going to pick this section right here. It's around like 2009 to 2011, 2012, right here. Why would we get a flat line? Why would there be no increase and no decrease? What would be happening? So if an increase is more are surviving and more are having babies, and there's just like a more plethora of these moose that are living and thriving, and a decrease means that they're dying, what happens if it's a straight line? I want you to think about that. So in box F, I will explain kind of what we just talked about. What does it say? How do we explain these times? Oh, we kind of went through it. Okay, so overall, we need to, or what we like kind of went through is we're thinking about what all the times of increase had in common. What did all the times of decrease have in common? So overall, what fundamentally at the core is the reason that the moose population increases or decreases during any time interval, no matter what? Maybe they got eaten by a wolf, maybe they had a disease. What does that come down to? So we're just going to write all this down now because now I kind of talked you through it. So I know there's like this huge gap in your notes. I'm sorry. I don't know why it was doing that. And I also realized that you like can't really type on this unless you do this weird thing where you double click. And now we're going to type on it. So I do apologize for that. So I'm just going to have a text box here. And so our question was a specific area that you talked about. So we talked about, just together, we talked about 1966 to 1973. So 1966 to 1973, we said had an increase in moose abundance equals more moose were having babies and staying alive. Our next area that we looked at was this yellow one from 1974 to 1980. So 1974 to 1980, there was a decrease in moose abundance. Oops. There's a decrease in the moose abundance, which overall we decided that was the moose were dying. Eaten by wolves, die of starvation. What else is not enough food? Things like that. Okay, so that was, I think, everything on that one. I don't even know how to like make sure that this gets shared. I'm gonna zoom out. Oh, here, save and close. Awesome. I'm glad that worked. All right. So then on this, oh, am I gonna have to do it again? This is annoying. I'm really sorry that this did not work out. Like it's not editable. That's really unfortunate. Okay. So I asked you, I left you on the slideshow, what fundamentally determines a population change? We kind of already said it. It's way more simple than you probably think, and it's births and deaths. All right. I'm not really sure how to get this next idea down, but we will figure it out, right? We always figure a way. All right, so we did all that. We wrote it down in box G. Awesome. All right. So this is our model. I want these graphs. So we're gonna think about what is true about birth and death when the population is increasing or when it's decreasing. What happens, like I said, what happens if it's staying the same? I don't know how to like make a picture. So again, like I said, you're gonna bear with me, guys. Oh, here. Oh, but I want them all together. So I'm gonna, maybe this will work. Here we go. Hopefully. Let's copy this. Oh gosh. I have no idea how this is gonna turn out. You're gonna learn with me here today, guys. Did it work? It worked, but it's all the way over here. Okay. I want to make it smaller. Oop, oop, what is happening? How did I do that? Oh my gosh, I'm so sorry for these technical difficulties, but you know, you live and you learn, right? Oh no, I forgot the increases. Okay, here we go. Whoop. Well, there you go. That looks right, right? All right, so an increase. This is an increase. And then I'm gonna copy. Oh, this is so frustrating. Okay, I'm gonna copy this again. Paste it over here. Hopefully it works. Oh gosh, oh gosh. Okay. Whew, I'm like sweating over here. This is hard work. And then I want to this downward line. Copy. Like I said, I'm really sorry if like you guys can't edit this very well. Do the best you can or take the notes so that you can understand them. You just need to know what the downward trend means and what kind of the upward trend means. There we go. I want to make it more clear for you. Okay, now I need my text box. So overall, this one is increasing. Also, I don't know if you can hear that, but one of my cats is like messing around in the kitchen. And this one over here is decreasing. Awesome. Okay. And then our ideas. So what we are supposed to be going through is what is true about these. So like when would the population be increasing? So let's think about that. From the game, what types of things were true or what was happening when the population increased? So from class, a lot of people said babies, like reproduction. I don't know why. Why my life is so hard today. I hope you like my singing. All right, number 2. Food availability was a big one. And the last one, you guys told me less predators. So less chance of getting eaten. I might have to make this smaller text-wise. I'm not really sure how. It's just a learning day to day. Maybe I can put it in there. There, okay. And then text, new box, for when would it decrease? So times the population would decrease. You guys came up with if there was not enough food. You came up with if there's too many wolves. If you said that there was less chance of finding a mate. And if there was not enough space or habitat for them to live. All right, and again, I'm gonna have to make it smaller. I hope you like my sound effects. It's gonna be a really good video for you guys. You're gonna be real happy to have Miss K as your teacher. I'm really not like sure where to put this, but hopefully you can read that. Okay. And then I did ask you this question. We're just gonna put it down here because obviously there's not enough room because you know this is just a task for Miss K. So you guys I asked the question about what happens if it's a stable population. You guys told me fluctuating populations in a population graph, when it those ups and those downs that we talked about, that is actually stable. Like, you want that. But what happens if it's a straight line? So my question is, what about a straight line? That is when birth rates are equal to death rates. All right, so I'm going to just like move this up a little bit because it kind of goes with that box. All right, so I never specifically told you our driving question, but it was when I asked you guys, like, what's going on with the moose population. So here it says, back to our driving question, why is the moose population fluctuating? Remember those ups and those downs. So why is it going kind of all over the place? So now from what we've learned, I just want to put all our ideas together just to answer our question. So we're going to write it right here. I'm going to write, question. What causes the increases and decreases, fluctuations in the wolf population graph? I'm glad I can spell today. So that was our question. I know I never like specifically said it, but kind of what we've been investigating this whole time that we started this unit out with. Excuse me. So hopefully you guys have found out or figured out that it is the different factors that are going on. And we've named them all multiple times. It would be the availability of food. It would be predators and prey. It would be disease, weather, mates, space. What else do we say? Ability to reproduce. I think that is everything. And then if you just think about things, so a lot of these could be both these different factors. So when we were in person, I would just go over this with the classes. I'll just kind of give you a few examples here. How do specific factors affect populations? So think about it. How does food affect a population? If you have food, if you have an abundance of food, extra food, there's probably going to be an increase in populations. If your food is limited, they might die out because, like, if there's not enough food for all the animals, they might die out. If there's more predators, what's going to happen? You're probably going to die out. If there are diseases, what's going to happen? So all of these factors have an effect on populations, and we kind of needed to know all these factors in order to find out what exactly was going on with the wolf and the moose. So I'm going to save and close that. I have no idea. Oh, look, it showed up. And that is the end of this note. Again, do not turn these notes in. You do not need to turn these notes in. It is not necessary. Please do not do it. Because you can use these on your test, which you are going to have before you leave for Christmas break. If you turn these in, unless you ask me to return it, I'm not returning it to you, and then you don't have notes to use. So that was all. I hope you enjoyed my presentation and the struggles that I had, and I will see you all tomorrow or next class.